Let us study electrolysis of molten NaCl. Okay. Now say, as you know, there are two types of these cells, electrolytic cell and galvanic cells. Okay. One is electrolytic cell and galvanic cell or voltaic cell. So these are the two types of the cells. Okay. Now in electrolytic cell, that is electrical energy is converted to chemical energy, and in galvanic cell chemical energy is converted to electrical energy. Now electrolytic cell, the process carried out is called as electrolysis. The process is called as electrolysis. Okay. Now here we are going to see electrolysis of molten NaCl, that is electrical energy is converted to chemical energy. Okay. Let us say one by one the process carried out. Now here this is the electrolytic cell, or it is a container in which fused NaCl is placed. Molten NaCl or fused NaCl is placed. Two electrodes are immersed in the fused NaCl, that is carbon rods. This is negative, that is one which is connected to the negative terminal of the battery or direct electric source, that is cathode, and it is anode. Okay, which is connected to the positive terminal of the electric source battery. Now see, when the connections are made, the process of electrolysis is started. That means the decomposition of NaCl starts into individual product, that is the formation of Na, sodium, is at cathode. That means here Na plus ions of NaCl gets attracted to the negative terminal of the cell, that is negative electrode, that is cathode, and they are discharged at neutral as a neutral sodium, Na, fused Na, and Cl minus ions gets attracted towards the negative electrode, that is positive electrode, and here these Cl minus ions are discharged as chlorine gas, Cl2 gas. Now the electrolytic reactions, the reactions of electrolysis are studied as under that is the reaction taking place at individual electrodes are written here. The one is oxidation half reaction at anode at positive electrode. At positive electrode the Cl minus gets attracted, is it? So here 2 Cl minus in bracket in the form of liquid, 2 Cl minus to form Cl atoms plus 2 electrons. Here oxidation takes place, which is a primary process. Now these two chlorine atoms combines to form chlorine gas, Cl2 molecule, which is a secondary process, and primary secondary total net process here at anode is 2 Cl minus, which forms Cl2 gaseous plus 2 electron. This is liquid. Okay. Now this is the reaction at positive electrode, which is called as the anode of the electrolytic cell. Now the next is reduction half reaction at cathode at positive, the reaction taking place at negative electrode. Reduction half reaction at cathode. Now Na plus being positive gets attracted towards the negative pole of the battery, accepts one electron, formation of neutral sodium in the form of fused state, which is the reduction. This is reduction. The oxidation takes place at anode, positive electrode, and the reduction takes place at cathode, which is negative electrode. Now the combination of two half cell electrodes, that is which is a net cell reaction. This is the reaction at anode, this, and this is the reaction at cathode. The combination of these two, the two electron gets cancelled and 2Na plus twice of Cl minus, which gives 2NaCl plus Cl2 gaseous. This is the net cell reaction. Okay, so this is the electrolysis of fused or molten NaCl. Now what are the results of this electrolytic cell? Results. Okay, see the results of the electrolysis of molten or fused NaCl. Here a plain green chlorine gas is released at anode. Pale green gas is released at anode. And second, a molten silvery white sodium is formed at cathode. Okay, so these are the two results. So decomposition of NaCl into metallic sodium and chlorine gas is a non-spontaneous reaction. Why it is a non-spontaneous reaction? Because we are made to occur the reaction by the supply of electrolysis, with that is electric current. Without the supply of electric current, the process cannot be carried out. So it is a spontaneous reaction, and the electrical energy supplied by the battery forces the reaction to occur. Okay, and here one more thing, the Cl minus ions are discharged at positive electrode, giving 2 electrons, and these electrons migrates towards the wire and through the battery. Again they appear at the negative electrode in the battery, which are taken by Na positive ions. So the electron neutrality is maintained in this process. So this is the electrolysis of molten NaCl. Now let us see the electrolysis of aqueous NaCl. Now see, to study the electrolysis of aqueous NaCl, the assembly used as it is in the previous case in the electrolysis of molten NaCl or fused NaCl. That means the container, the electrode and the battery supply, whatever diagram we have used here is same. Here only the molten NaCl is replaced by aqueous NaCl. Okay. Now let us see directly the reduction half reaction. While the electrolysis of aqueous NaCl, the reactions taking place at individual electrodes, that is one, reduction takes place at cathode. Okay, what is reduction? That is the gain of electrons. Now cathode is a negative electrode, the positive Na ions are gets attracted toward the negative electrode and they get reduced. Na plus ions takes 1 electron to form neutral sodium. Okay, now it is the standard reduction potential which is given. Now simultaneously at cathode, water molecules also gets reduced in this way, 2H2O plus 2 electrons to form hydrogen gas at cathode and 2 OH minus ions. The standard reduction potential is this. Now here in this case, standard reduction potential of water is much greater than the reduction potential of the sodium. That's why water has a greater tendency to get reduced than sodium metal. So hydrogen is liberated at a cathode. Now at anode, oxidation takes place. Okay, what is oxidation? The loss of electron. Okay, now the positive electrode, the Cl minus ions are gets attracted towards the positive electrode. That's why here the reaction is 2 Cl minus to give chlorine gas by giving 2 electrons, and this is the standard oxidation potential. Now simultaneously water also gets oxidized in this way, 2H2O to give hydrogen gas 4H plus ions and by giving 2 electrons, and the oxidation potential is this. Now here the oxidation potential of the water is higher than the oxidation potential of Cl minus. That's why water has a greater tendency to get oxidized than the chlorine, is it? But practically chlorine gas is liberated. It is found that chlorine gas is liberating at the anode That's why the main product is, that is Cl2, and there is a simply oxidation of chloride ion to form chlorine gas. Now overall reaction, let us see overall reaction of the cell. That is, this is the anodic reaction, which is this, that is 2Cl minus to give Cl2 plus twice of electron, chlorine gas is formed. And at cathode, only being the tendency of reduction is higher in the case of water than Na plus, that is 2H2O plus 2 electron to give hydrogen gas and 2OH minus. Formation of hydroxyl ion takes place at cathode by liberation of hydrogen gas. So this is the net cell reaction. Okay, that is 2Cl minus aqueous, 2H2O liquid to form chlorine gaseous, hydrogen gas, and this hydroxyl ions. This is the net cell reaction. Okay, now what is the result of the electrolysis of aqueous NaCl? Hydrogen gas is liberated at cathode, the negative electrode, and chlorine gas is liberated at anode, which is positive. And here NaCl is converted to NaOH. Here NaCl is converted to NaOH, is it? Because unreacted Na plus ions combines with this OH minus ions, combines with the OH minus ion to form NaOH, is it? That means because Na plus ions remains unreacted and OH ions are formed at cathode, NaCl solution is converted to sodium hydroxide NaOH. So this is the electrolysis of NaCl.